There are various applications that the Nor145 is built for, including what we call onboard building acoustics measurements. Nor145 can be configured with various different options and option packages, depending on what the applications call for. One of them, as mentioned, is building acoustics, and that can be configured with two different option packages called BA Basic and BA Advanced. The BA Basic is the basic onboard building acoustics calculations package, and that enables reverberation time, decay and calculation of Tmax or early decay time, T15, T20, T30. Those are pretty standard reverberation time measurement metrics, and these can be based on either impulse or noise excitation methods according to the ISO 3382 standard. Along with this option package, the meter comes equipped with an onboard signal generator with sine, white, pink, or bandpass filtered noise. And it also includes building acoustics measurements according to the ISO 16283 series of standards for airborne or impact insulation testing. So then the next upgrade to that would be the BA Advanced option kit. So in addition to the BA Basic, the BA Advanced option kit includes building acoustics measurements according to national standards. So in addition to the ISO 16283 standard, now we get the ability to measure according to ASTM standards, common ones being E336, E1007, the E336 being the airborne sound insulation testing, E1007 for impact insulation, as well as the associated ratings for calculating the single number ratings with those measurement standards. And then other ISO standards like the traditional 140 series, the British standards, German standards, so on and so forth. This option also enables the pause and continue button with back erase features. This is especially useful if making a measurement, maybe a sweep of the room, and I don't know, we accidentally sneeze or we trip over something, we essentially make unintentional noise. So instead of starting the measurement over, we could press the back erase button, and that will set us back for a predefined number of seconds. So that includes onboard post-processing, such as excluding measurements from an average for source and receiving room levels, adjusting reverberation decay curves, etc. It also includes the rating of service equipment according to a specific ISO standard. And then this is where we get the ability to control Norsonic's wireless Nor282. So Norsonic has two different amplifiers available. This is the standard Nor280 power amplifier, which requires external power. It can be remotely controlled using a key fob here. It has a built-in signal generator with traditional white-pink noise. It also accepts an external input. And then this is the more advanced, the latest Norsonic Nor282 power amplifier. It is battery operated. It features advanced signal generator, also remote capability with Nor145 as mentioned. It also does include a key fob for still a manual way of turning it on and off. The Nor Virtual software allows us to control Norsonic's line of sound level meters using a PC. So whatever we do on the PC, it reflects on the physical device connected to the PC, and whatever we do on the actual instrument reflects on our screen here. So this is compatible with Norsonic's latest sound level meters as well as Rheon's NL53. So what we want to select is the building acoustics mode here. The next screen that appears are the default setups with the meter. If we had any customized setups, this is where they would also appear. So in this case, we'll just select airborne. Following screen that appears, just a simple overview of the setup for that specific measurement. So right now we're just selecting a default airborne. So those are the settings associated with that setup, but we'll go in a little bit over how to change the different settings for a specific standard and for settings that we specifically want to measure. And before we do anything here, let's first define our settings. So that's done by navigating to the setup menu by pressing the setup button. Here we have different submenus. And the first ones I like to start off with is the rating, because that's really the most important one. We'll go ahead and click on that because we click the default associated with the meter. We are measuring according to ISO 16283 standard. So let's start there and change our standard. So here we see a selection of different standards available with the meter in the US and Canada, North America. Generally speaking, we test according to ASTM standards. Next, we can select whether we want to do an airborne or impact measurement. So we'll leave it on airborne. And then the next will be the standard, which this is the E336 standard. Now, once we're happy with our selection, we could either use the check mark here, or we could use the hard button here. Next, we want to define our volumes associated with source and receiving rooms. So here we can define the dimensions in meters to get our volume. Here is where we can define the temperature, pressure, and humidity. Now, one thing I'll mention about the ASTM standards is that when it comes to temperature, pressure, and humidity for the source room, it is not required. However, in the receiving room, the temperature is required. It's a requirement, and that has to do with specific ratings. If we want to calculate the apparent ratings associated with E336 or E1007, then the temperature is required. And that's because that involves the calculation of the absorption of the receiving room, which involves the calculation of the speed of sound, which requires temperature. And that's actually something that we have mentioned in a blog on our website that can be found on scantecinc.com under blogs. And we have a little bit of information on reverberation time, decay rate, and we talk about specifically the E2235 standard that is referenced in these airborne and impact insulation standards for measuring the absorption of the room, which is part of measuring reverberation time and the decay rates. Norsonic has two types of calibrators. Nor145, which is a simple calibrator generating 1 kilohertz tone at 114 decibels, and then they have a 1256 that can generate a 94 decibel or 114 decibel tone at 250 or 1 kilohertz frequencies, and those could be toggled in any combination. Now, in addition to that, it also features measurements of relative humidity, temperature, and barometric pressure. It's especially useful when we're making building acoustics measurements and we need to measure the temperature for the ASTM standards. All right, other things that we can enable here. Background corrections, that's a requirement as part of ASTM standards, so we want to make sure that those are activated. We have the option of deactivating it just to see if what kind of a difference that makes if we wanted to do some maybe research or investigative things. We have that capability. In terms of the 1/10 decibel index, that's if we want the ratings in 1/10 decibel format. Again, that's not per the standard. That's just to see, maybe how fractionally the measurements change. And then we have the C values. These are associated specifically with the ISO standards, so this is irrelevant for ASTM. And then we get to select how we want the reference curves when presenting the ratings to be presented. So do we want to fix reference curve, or do we want that reference curve to shift as according to the calculated rating? And the adjacent band test, this is a test in the source in the sending room that evaluates how the 1/3 octave band noise compares within the adjacent bands. All right, so let's click on level here. All right, level is where we define the duration of our measurements. So for level duration, this defines the the duration in the source and the receiving rooms. We can also define a separate duration for our background noise. This is where we can define our filters. So according to the standards, we have to measure per 1/3 octave band filters. So that cannot be changed. If we wanted to extend the lower end frequency limits for the transmission loss measurements, this is where we can do that. But otherwise, this is sufficient to meet the standard. Went too far, but I think we covered most of it here. So if we have multiple source positions, this is where we can define how many source positions we have. And then this is the pause back erase. This is how many seconds we want to go back in the event we want to erase some data as we're making a measurement. Setting will be reverberation. It doesn't have to be in this order. It could be in any order. But here is where we can define, again, if we're measuring in 1/3 octave bands and what our filters, what our frequency range is. Here is where we can define the type of excitation. So we can define whether if we're measuring using the noise or impulse. If we're using impulse, we can define our trigger levels. So once that impulse is activated, what's trigger? How is the meter triggering it? And then the trigger frequency. Then here we can define our max expected reverberation time. So it's in increments of 4 seconds. So this is a good default here to leave at 4 seconds, because I can't imagine when measuring the transmission loss of smaller spaces, we would have anything more than that. I could be wrong. And then minimum distance, noise to floor, distance, minimum distance, noise floor, sets the minimum difference between the lower calculation range for the selected RT function and background noise level. And then here we can define what's the primary RT that we're trying to capture here. So is it a T15, T20, T30? And then here we can activate whether we want ensemble averaging. And then here, this is a handy one if we're doing repetitive reverberation time measurements in multiple locations, maybe while the meter is on a tripod, or if we're holding it, it just allows us to quickly go through the measurements. So we can define whether we want to do 3 consecutive reverberation time measurements, whether there's any pause between them. So this is where we can define that and activate it if needed. Otherwise, if we want multiple reverberation data sets, then we have to just manually start those, which could be fine too. We have a signal generator that allows us to use the onboard signal generator if we don't have an external source that we're feeding into our loudspeakers. So this is useful for doing things like reverberation time measurements. I imagine if you're doing airborne measurements where you need the speaker in the source room, it's really hard to feed a cable from the receiving to the source rooms. However, if you do have the Nor282 wireless amplifier from Norsonic, then this would be a useful feature. Memory is where we define how we want our measurements stored. So file name base, it's a prefix to our measurement files. In this case, we were demoing this at an ASA conference, so that's what we have here. So basically, any measurements, if we're to activate this and define this, any measurements that we save would start with that file. Here's where we could also manage our setup files. So using this menu, we can save our custom setup. So once we're happy with our setup, this is where we would navigate to save it, and it would appear in our list of setups. Now let's get back to the measurement screen here. Pressing the function button toggles the different measurement types. So the measurement types are described in the top header here. So right now we're measuring the level in the source room. That's what the S is for. So if we press the function button, now we would be measuring the background noise, and that's in the receiving room. And here we would be measuring the reverberation time. And again, that's in the receiving room. So that toggles the different, and then finally the receiving room level. So with the source on in the source room, in the sending room, we're taking a measurement in the receiving room. If we press the table button, we can toggle between tabular and graphical view. Pressing the info button will give us more information about the different settings. And then we start a measurement by just pressing the start stop button. I don't have a setup here, so we could just start the measurement. As mentioned before, that's based on what we had defined in the measurement settings. So we could either let the measurement run through, or we could stop it manually. All right, so now after the measurement is complete, we can inspect it. If we like it, we could accept it. If we don't like it, we could decline it. Now, because we started a new measurement, we haven't saved it yet. So after we complete the first measurement and we accept our results, it will ask us if we want to store it. So here, we could also change the name if we wanted to. I'll just click OK to accept it. So now, once we go through the different functions and we have all our measurements, the final results can be viewed by navigating to Project. This is like, I would say, a home button for viewing the different measurements. This is also where we can import other measurements. So if we had a different project and we wanted to reuse some of those data sets, this is where we can do that. And to do that, we could just simply use the arrows here. So let's say we wanted to reuse the background noise of a specific room. We'll select that, import. That will navigate to the memory, and now we can select one of the measurements that we want to import from. Let's click this, and now let's say we want to import background noise. So I suppose, yeah, it doesn't matter which one you have selected. It will ask you, will prompt you what data set you want to import. To start a new measurement, you can press the X button. It will ask you, do you want to start a new project? Do you want to save the measurement? Yes. All right. And another way of reusing data is this way. It will ask me, reuse current measurement data. Say yes. And now it will ask me, okay, which data sets do you want to reuse? So we only have data sets for receiving and background noise. So I can select what I want to import or reuse in this case. Okay, let's now just pull up an existing measurement since we're not going through. We'll go ahead and save that. We're not going through an actual measurement sequence. No, I want to open ASTC here. All right, so now this is the screen that appears. It's that project window. Now we can see the calculator ratings here. And we can view details of those measurements by clicking on the view button. And we can keep clicking the view button. And that will give us more information about that. If we click the function button, now we're going to toggle through the different ratings. Now we see the NIC and the NNIC. And as you see, this is the curve. So the curve is being shifted based on the calculator ratings. And this has to do with the settings I mentioned before. And let's see. So that's essentially the summary of doing an airborne insulation testing project on the Nor145. Now, we also, one of the newest capabilities on the Nor145 is the ability to measure the high and low frequency impact ratings. So these are two different standards. The ASTM E3222, that's for the high frequency impact rating. And it's based on existing insulation measurements, but the actual rating uses a smaller frequency range. And This rating is based on a reference curve, and the purpose is really to evaluate high frequency performance. And then the other one is the low frequency impact noise rating. That calculates the low frequency impact rating, the LIR, and that's simply just calculated from 3 frequency bands at 50, 63, and 80 hertz, 1/3 octave bands. It is not based on a fitted curve, and you could see a quick summary here. And the purpose is to describe low frequency of impact noise or thudding, generally by footfall on lightweight structures. To calculate those ratings, it's really straightforward. So if we have, share my screen again. If we have an existing measurement, let me pull up this one here. So here's our standard apparent impact insulation class rating and other ratings associated with that. If we wanted to see what the high frequency or the low frequency rating would be, we simply just we could create a new project, reuse the same data, or what I'll do right now is just go to setup, rating, it's grayed out. So because I'm changing things, I actually have to, this is a good demonstration, I have to activate this measurement. So let's activate it. Activating means that I want to change it. I want to either add additional data sets to it, either for the receiving room or reverberation, or I need to activate it if I want to change the rating. This is one way of doing it. Another way would be just to create a new project and reuse the same measurement data, or create a new project and import it. So now it's activated. We'll go to rating here. And because we're measuring, we have it defined for impact, now we have this additional drop down here for subtype. This is where we can select whether we want to calculate the high frequency or the low frequency ratings associated with those, with this measurement. So let's pick high frequency. This is just giving me a warning that I've changed the rating, so my results will now change. Do I want to continue? Yes. Activate. So we're going back to the measurement screen, and because all my measurements are already done, we'll just navigate to project. Now we get our apparent high impact rating and the other associated ones, just high impact rating. Similar process for the low frequency, the low impact rating. In this case, because it is fitted against the curve, we'll see that curve here. It's again limited from 400 hertz to 3150. For the LIR, the low impact rating, we wouldn't see a curve because it's not calculated on a curve. We would just see a calculated rating here. Okay, so that's everything in terms of, we're gonna go over, I hope some of you can still stick around, but that sums up how to make a measurement on Nor145. Now, in terms of transferring measurements, we use Norsonic's NorConnect software. So that this software is used for transferring measurements from the 145 or the 150 to the local PC. It's also useful for viewing the measurements. So to filter our measurements based on our building acoustics measurements, because there are other measurements we could be making with the Nor145. So to quickly filter through them, we have to change our mode here. That's done by selecting building acoustics. So we'll start there. I have my Nor145 connected to my PC via USB, and Nor145 automatically recognizes it here. So these are my building acoustics measurements that I have stored on the 145. To transfer them over locally, we could just do a simple drag and drop operation. So I already have some files here. And once we do that, you could simply just double click on the measurement file to open it up. So then we're greeted by this screen here. This gives us an overview of the data sets. Here we can, do things like fill out these different areas for generating a report. So once we have those filled out, we can go ahead and navigate to the reports section of Nor145. Here we can do a simple overview. Overview just does a data dump of all the different data sets, but we also have this handy project report. Right now it's generating the report in Excel. And I should note that that's based on whatever rating we have selected here. So right now we have the ISR and ISR, and then finally the parent IIC, that's for impact insulation testing. And this is the report. It just populated on a separate screen for me, but this is what the report looks like. So because we had the ISR selected, that's the report that we generated. If we wanted the AIIC, we would just go ahead and click on project report again. All right, and quickly about reports. So here we can visualize the graph. We can see the results table, background corrections table, our raw data set, and then some information about the actual meter.